Thank you. Can you hear it?
Yes.
Okay, great. Then I will share my screen here. Can let's see my screen now?
Not yet, sir.
Got it. Okay, great. Okay, well, you guys can see this, yes? Okay. So, yeah, I want to talk. So we have about 15 minutes or 12 minutes or so.
You can go on, sir. No problem, sir. You have at least a half an hour ahead. No problem.
Okay, great. So, yeah, I want to talk about the future of energy in India. We've learned a lot. We've learned a lot in the United States over the years, developing solar projects, energy projects in general. We're a little ahead in terms of the amount of time and the lessons learned. Um, and we also have our own challenges. I actually am lucky to be on the computer here. The power was not on. So in California, we're having these power shutoffs, and even if you have solar power, your power may not be on because you don't have the batteries, you don't have a microgrid, and that's a situation I'm in. I've got solar now in this house that we recently moved into. We put solar on, but I haven't got my batteries yet, so I am was without power throughout the night. So that's why microgrid technology will be useful. One of the reasons, but other reasons would be that there may not even be power lines where you want to have the power. So this is a photo of a project from 10 or 12 years ago, maybe more, that I did. It's mounted on the ground, and the reason I showed this picture is because this is really the old way to do solar. You have the solar system here, but above you have these power lines. This is a grid-tied solar system. It's not able to run when the power goes down because it relies on the grid. So for safety reasons, solar shuts off. As many would know, when the grid shuts down, unless you have what's called an automatic transfer switch. And so this is really a first generation solar system. And you know what we're looking at now, where the real market movement is happening, where there's a big need, is with distributed energy, or sorry, distributed energy over long distances is what we have here. These power lines, and that's part of the net metering. Well, what happens if you don't have power lines? What do you do? And obviously, you know, not every part of the world has power lines. Certainly not every part of India, and there's parts of California, even nearby my house here, that don't have power lines. And so it's very expensive if you do want to bring power lines, if that is an option. But it's not always an option, and it's certainly not an economic option in many cases. So that's where wireless energy comes in, wireless without being connected to the utility grid, and doing it locally, using it locally, producing it locally, and using it locally is, in my view, the most efficient way for solar power to be produced and used is locally. If you were to compare from some of the leaders that are in the industry, um, that your power generation from the point of production to the point of use may be as much as a 30 to 60% loss of power across the power lines. So in order to transmit electricity over long distances, you're really losing a lot of that power. Whereas if you're using it locally, you're not. So there's a major cost to distributed energy, and there's a major loss to distributed energy. You're spending a lot of money for the power lines, and if you're using it at the end use, if you're a business, you're manufacturing electric vehicles, or you're just a homeowner at home, the majority of the cost is the transmission, not the production. So on one hand, you know, coal and nuclear and these and even large scale solar projects are very cheap, but that doesn't really matter when you have to spend a ton of money transmitting it. So transmission of power is very expensive and inefficient. And we have seen the cost of solar and energy storage come down so significantly that you'll likely still be able to produce power with the additional equipment cost of energy storage for less than what you would otherwise spend with the power to be transmitted. And so, so we live in an age now where wireless energy can be produced locally and used locally. This is a photo of a project that one of my first carports. I like carports when it comes to solar. You know, it's to me more about a philosophy than it is about technology or who the manufacturer is or any of that. Our philosophy is simply energy independence. So if you're an American, in this case, it's red, white, and blue. You know, everybody in America, for the most part, likes their independence, and India is very similar in its pride for entrepreneurial spirit and the idea of self-reliance. And so independence in general, I think, is an opportunity, a mindset that would work really well for India, especially when you develop the power that you need further and further for your country. So I see a big parallel between the American entrepreneurial spirit, which really is just an entrepreneurial spirit that anyone anywhere in the world has. There's a lot of people who come to America because of their entrepreneurial spirit, but it's exciting to see in India that a lot of activity is happening, particularly in electric vehicles, as well as solar power, and you have a strong drive right now, I can see, to produce as much of your technology in the country as possible. So I see, and I am excited by this this spirit that you have in India. So what really is an opportunity is the solar microgrids with energy storage, energy management, and electric vehicles. I believe that if you're going to develop the solar market and the electric vehicle market at the same time, you might as well integrate the electric vehicle into the development of the solar market. And the way to do that would be to have a solar microgrid with the transfer switch and a control system that manages your appliances. So maybe it turns things on and off just so that you don't you're not using too much power at any given moment. So you have advanced energy management software algorithms running on a panel, for instance, that controls the energy coming in and the energy going out. So a microgrid is just an energy control system that isolates and islands itself from a grid if you are tied to the grid, and if you're not tied to the grid, it can run independently. And so, you know, I believe that if you look at the cost of the batteries, that it may be prohibitive to do a large enough battery on a property, say for a home, you know, so some of those solutions are on a community basis. If this is a community of several hundred houses right here, everyone could actually have their own solar system, but they don't necessarily need their own battery if everyone's homes are tied together. And that's a lot easier to achieve than running major transmission lines across a country or across a community. So in this case, a small neighborhood, you could have all of these solar systems tied together and then use one battery. That's an option. But as well, an option is to plug in your electric car and to use the electric car as the battery source. Now, there are some efficiency issues, the round trip efficiency of charging and discharging an electric car. So you'll lose some power going in, you'll lose some power going out. But when you consider that the alternative is a battery by itself that doesn't also serve the purpose as a car, or when you consider that you don't have the option of power otherwise, when you consider that power has to be transmitted from long distances and there's losses already, then in my view, the losses are worthwhile in many situations to see the round trip efficiency losses from the electric vehicle. In India, I believe, are justified. That being said, there is opportunity for car manufacturers, battery operator, or the batteries inside the electric vehicles to have newer technology. And so I would encourage anyone interested in applying newer technology to the electric vehicle to essentially make it a power plant where it can roll around and discharge energy itself without necessarily a charging station. This is a concept that some companies have, but that the technology doesn't currently is not on the market for. So there's a person that I would have liked to join us, and maybe he can join next time. But there's a company that in the United States was funded to do research on a new type of power electronics, and I'm in an NDA, so I can't say too much. But what I can say is that it's the best technology in the world, and it would be available to any car manufacturer who wishes to use it. So if any of you are involved in car manufacture, or you'd like to experiment with making the electric car a power plant that can roll around in power buildings or be used for vehicle to grid technology, vehicle to home, vehicle to business, I believe 160 or 166 kilowatt charger can be built into the car. So you don't need a charging station. You don't need to build out the major infrastructure if you have a car with the charging station already built into it. It doesn't need to be expensive. It doesn't need to be highly, it actually can be cost effective. And so that's something that, since the last time I spoke with people from India on this presentation several times, that technology I was not aware of, and since I've been approached. And so that's an option. So anybody listening, if you want to message me about the possibility, if you're working on electric cars, to try out new technology, I would love it. But basically, the Department of Energy funded research, and the Department of Energy for the United States government funded research which will be capable of doing what I just described. But in the United States, there's a lot of red tape. There's a lot of bureaucracy. There's a lot of existing business models that would be broken if this were deployed. So the reason I'm excited to talk with people from India is that you don't have the hurdles to overcome. You don't have the red tape. You've got the entrepreneurial spirit, and you've got the opportunity, and as well as the need to develop new technology that would allow there to be no power lines. And so this is the technology, and it's the technology I've been waiting for. But basically, when you combine technology, you can accomplish more. You can do more with each piece. And so in this case, here's solar power, wind, and a car. Well, if you just have the solar and you just have the wind, you need power lines. But if you have the solar, you have the wind, and you have the car, you don't. So technology is stronger together. And the friends that have this technology I mentioned are, and the company is Seinwatts. They believe in maximizing the use of individual things. So your car or your home or your business might as well do more than one thing. So if you treat the car as not just a car, but also an energy storage facility and a power plant, you're getting a lot more value out of the car. And I believe that due to the cost of these cars and this technology and everything, that normally when you think of one aspect of the technology, you're limited. I mean, you may not be able to justify it financially, but when you accomplish more than one goal, and you kill two birds with one stone, then it can be justified financially. So I see a huge opportunity for India to leapfrog the need for power lines, for transmission lines, by maximizing the use of an electric car. So otherwise, if you don't use the electric car as a battery, you'll buy a smaller battery for more money than you would to already have had the car with the battery inside of it. Now, you may not have the car at home all the time. You may not, utilize the car all the time. But it is certainly an option, and it would reduce the overall size of the solar system that you would need, or the battery that you would need. So anyway, it's a huge opportunity, mostly to advance the deployment of electric vehicles. The more you can do with the electric vehicle, the better. And when we're talking about vehicle to grid technology, part of the reason that it hasn't really happened is because of the round trip efficiency and the losses associated with charging the car and discharging the car. This new technology, these new power electronics from America don't require or don't lose all that energy. So you can charge and discharge on a regular basis and really efficiently use the energy, which has never been done before. So I'm telling you about something that is going to revolutionize electric vehicles, but that is hard to accomplish in the United States because there's just not the kind of activity that's happening in the United States as there is in India on a development basis. Most of the electric car manufacturers in the US are big OEMs that have either acquired some other company or they're working with another company. They're very hard to get a hold of. So if we can work with new OEMs in India, then we can help India leapfrog, not just needing power lines and transmission lines, but also advance the most technologically capable electric vehicles in the world. So that's honestly why I'm excited to share this idea, is because along with the idea comes opportunity for anyone that's interested in discussing how to integrate these power electronics into the electric car to make it a lot more useful. And so, but that's basically the idea that I have, is, wireless energy using electric cars. And electric cars one day may be autonomous. So you could have electric cars driving around that have nobody inside of them, or just power plants. You click your phone or your phone automatically tells the car to come because you need more power. So power can be delivered now using cars and or vans or trucks. And so this new wireless electricity is a huge opportunity to avoid major infrastructure costs. But as well, what's really neat about it is the electric car can pay for everything. Instead of having transmission lines here, a car there, a battery here, a solar system there, you have everything utilized most efficiently in one package. And that requires the right technology and the right philosophy. And in this case, that's the direction that we're going. And I see the biggest opportunity is for India with the technical skills to build everything. So what I would recommend is that, India continues to move in the direction that it is, where it's building and making and having the training and the technical understanding about the electronics in India. But essentially we could assist the deployment of this new technology that would for the most part be built in India using the US government funded technology, which is a unique opportunity. And the reason I would bring it to India would be because I see the difference that it could make is much greater there, as well as the resistance to the disruptive innovation that would occur, that would essentially completely turn the business model of the utility markets, the oil markets. Everything would be turned on its head. Whereas in India, that wouldn't be a problem because there is not so much infrastructure to put people out of business. But if you really think about it, I'd appreciate you guys to think about the impact of power plants rolling around and what that would do for your country. And then anyone interested, reach out. We're on LinkedIn. So I'm on LinkedIn. Please find me on LinkedIn and let's connect. I'm Les Mood. And then hot energy news every day, Monday through Friday. We're covering 5 stories that are the hottest stories in the world related to energy. We talk about electric vehicles. We talk about solar power. We talk about microgrids, wind energy, geothermal, any type of energy, hydropower, pump storage. So all of these developments that are happening on a daily basis are covered on Hot Energy News. And so we try to stay on top of the latest developments and share that with the world. I encourage you to please find us on social media. We're on Facebook, LinkedIn, YouTube, and Twitter. If you search for Energy Independence Group, that's our company. We cover the hot energy news. So if you're looking for us, search for Energy Independence Group, but definitely where I'm most active and easiest to reach is on LinkedIn. And that's where, as a professional platform, you don't have to see all the crazy people that are talking about weird things, commenting weird things. It's more professional on LinkedIn. So I do prefer LinkedIn. So if you want to connect, I'd encourage you to connect again, for information on hot energy news and to collaborate possibly. And then if any of you, I would please encourage you, if any of you know or may be involved in electric vehicle battery development, we'd like to discuss applying these new power electronics to bidirectional power electronics to the battery so that it can charge and discharge in a highly efficient way and essentially be a power plant. And that's what I am very excited about. I hope that there's some people here that are also involved in the electric vehicle battery development, and we can talk about how to.
Yes, a couple of quick questions to you, sir, from our participants. First one is, how e-vehicle is eco-friendly?
How are electric vehicles eco-friendly?
Yeah.
Yeah, so electric vehicles are mostly made with lithium batteries, which require, mining of cobalt, nickel, and lithium. So they don't exactly start out being the most friendly in that way. And they do need, the batteries will eventually need to be recycled. And the good news is there are companies that are recycling lithium batteries now. So if the batteries are recycled, then you could say that there was little environmental impact. But yeah, you'll see a lot cleaner air in your communities, a lot less noise pollution. So if say, in one of the bigger crowded cities where you have a lot of motorbikes, if you could electrify your motorbikes, imagine how much quieter it would be. And motorbikes seem to have the most pollution, much like lawnmowers and weed eaters. So those smaller engines pollute more than the bigger ones. So, but yeah, the electric vehicles will reduce your overall air pollution in your cities, smog, and that the impact that has on health will be minimized. As well, some people are concerned about the amount of carbon in the air. Decarbonization is possible with electric vehicles. So if global warming is real or not, it won't really matter. But if it is real, this will help. And if it's not real, at least, we help with some of the air pollution in the cities, in the smog. Since the lockdown happened in California, we live in a valley, and all the pollution from Los Angeles and San Francisco, it comes into our valley because it's lower. Well, since the lockdown, our air has been a lot cleaner. So that would be a good example of what would happen if more and more people were driving electric vehicles. The issue in the United States is that electric vehicles, the more that happen, our grid isn't going to be able to handle it. And it's already driving up demand for electricity dramatically as the market shifts to electric vehicles. The opportunity in India is you would want to deploy solar at the same time. as your electric vehicle. And if your solar and your electric vehicle are working together as a microgrid, you can justify, you can more easily accomplish doing solar by having the electric car. So if you don't have a utility grid running to your house, what are you going to do? You need batteries and you need solar panels. Well, if you can avoid that battery cost because your electric car is serving that purpose, now it makes solar more affordable, and the solar makes the electric vehicle more affordable. But as far as the environment goes, it would be good to air quality, mostly on a community basis. That would be the most immediate effect you could see, is cleaner air for your community.
So one more question to you, sir. What are the different type of e-vehicle batteries and recharge methods which are efficient, according to you?
So what are the different types of batteries and recharge methods?
Yeah, which is efficient,
Well,
according to you?
I'm personally not the power electronics engineer, but the main batteries that are being used are lithium. There are some nickel batteries being used. There's different types of lithium. As far as the battery type goes, to me, that doesn't matter as much as the power electronics that convert it. You'll find whatever batteries you use, if they're saying 48 volts, can be used with the Scienwad's power electronics. And the key is to convert and to move the energy bidirectionally in the most efficient way. So when the energy goes into the battery through the power electronic, you don't want to lose power. And when the energy comes out of the battery through the power electronics, you want to maximize. You don't want to lose that either. So my view, the most revolutionary aspect of the electric vehicle's capabilities is the power conversion, not the power storage. So we can take any battery stack or set and apply these inverters to them to essentially be able to operate a lot more efficiently. So normally an electric car, so the different types of charging methods, normally you pull up to a charging station and you have level 1, 2, or 3 charging. And so level 1 is the slowest, level 3 is the fastest, level 2 is in the middle. So, but normally you have to pull up to a charging station and you have to find one. And that's what the problem is also in the United States, is what comes first, the chicken or the egg. Tesla built a bunch of charging stations because they were smart. So they did that at the same time they sold their cars. But one of the problems with deploying electric cars is going to be, where are the charging stations at? So when it comes to deploying solar, electric vehicles, you have 3 major challenges. 1, to put in the solar. 2, to put in batteries. And 3, where are you going to charge your car? All 3 of those would be solved by building the charging station inside of the car. And it would automatically be part of the car. So instead of needing a standard worldwide plug, and they keep changing, the standards are changing, who knows what the standards will be in the future. Instead of that, imagine you could just plug your car in with the normal plug, a heavy duty plug, and you could charge a building. So you pull up to the grocery store and you say, you know what, I'm going to sell my electricity to the grocery store while I'm sitting here because I have some extra power. And then the car would automatically track through blockchain, through artificial intelligence, blockchain, a system that would know exactly how much energy you're putting into the building and all of that kind of stuff. So any participant in the marketplace would be able to utilize this peer-to-peer network. So basically each car could be a power plant with a peer-to-peer blockchain network, to where if you're charging your car somewhere, you get billed for it from the supplier of the energy. If you're powering a building with your car, then you can charge for that. So it's all a series of technologies combined into one would be an electric car, energy storage, vehicle to grid, and a peer-to-peer energy network that would allow you with your car to be a power plant. And if you had an autonomous car, your car could roll around and make you money while you're sleeping, maybe. So there's a lot of possibilities, but the main thing is the power electronics. The bidirectional inverter is really going to allow the greatest potential for the car to serve far more than just one purpose of driving you around. So we want to maximize the use of the car to make it part of the electrical infrastructure.
Sir, on behalf of our institutions and all the participants here, we would like to thank you for spending your valuable time with us and sharing your thoughtful inputs and about the futuristic prospects of e-vehicles. Sir. Thank you very much, sir.